Hello and welcome back here to our program on the industry stage at the Formnext 2024 in Hall 11 and at the live streams at home. When you're considering additive manufacturing as a solution or probably a way to optimize your production, the thing is that companies often focus on challenges that have already been streamlined or even solved. So thinking outside the box, reimagining processes entirely with AM, that can be really, really difficult. And I think we can all agree on that, right? So, of course, on a day where we talk about success stories, we invited a person that probably can solve this problem and has a new approach about to challenge this issue with finding the right approach to AM. Our next speaker, Philipp Süß, is an owner of an engineering office, and he will present us an approach to solve that issue. And therefore, I'm very happy to have Philipp here on stage, and he brought something with him. Philipp, great to have you.
Welcome. Welcome at Formnext. Many of you might have had the same experience that I had when I first saw an additive manufacturing machine. Maybe even today here at Formnext. I remember that day very, very well. It was about 15 years ago. I first saw an additive manufacturing machine at our hometown university, and I was mind blown. I knew this is something new. Here, a new era has started. From that moment, I focused my whole career on making sure that additive manufacturing is actually applied effectively in industrial applications. However, over the years, I quickly learned it isn't that easy. Especially deciding where that technology is the right technology for the job and where it is not can be quite challenging. Let me quickly introduce myself. My name is Philipp Süß, founder of Süß & Friends. After working in research on developing new material models for additive manufacturing to make sure the parts actually perform like intended, or developing post-processing mechanisms to ensure high-quality surfaces within internal fluid chambers, I changed into the industry. I worked many years in the automotive industry to bring additive manufacturing into that technology, into automotive. However, after a few years, I noticed it is always difficult. Matching the technology to the right job seems to be quite a challenge. And that not only for the big companies, even more for the small ones. That is why I founded Süß & Friends, together with two colleagues, Tim and Timothy, in 2017. We are a small team of additive manufacturing engineers. And what we do is pretty simple. We guide companies on their journey to decide first, is additive manufacturing the right technology for us? And then as engineers, produce the parts. And more so, develop the parts to be produced on the machines of our customers. Many of the parts we designed are now in continuous production for more than 6 or 7 years. Some of them I have with me and I want to show you soon. Quickly, let me say what we do differently than many other in the industry. I believe that engineering is key. Finding the right application, thinking differently, and creating new products for serial applications is key if you want to use the technology. This is why I decided early on to be independent. We don't sell machines, we don't sell materials or software, we design parts, and this way we can say no. Saying no, in my experience, is the most important word in additive manufacturing. Too often this technology is pushed in applications where this simply isn't the right choice. We specialized. Focus on additive manufacturing means we can actually make uses of the technology for its best. And that means we say no to customers that simply are not the right fit. And then maybe the most important one, value creation. Additive manufacturing is not a toy, it's a tool. And it doesn't lead to profit. If it doesn't lead to value, then we simply shouldn't do it. We're called Süß & Friends. because we think that in the end we need to work together with other experts to create a full process cycle. Also, we don't sell machines. We guide you through the process of deciding what is right for you, what are the processes needed after the machine, and how to actually build the trust and the knowledge and in your company, within the people, and making sure they apply the technology effectively. It's often said that additive manufacturing is unique, but why is that? I always summarize that on 3 main points. First, in additive manufacturing, we don't need tools. We don't need the initial investment in new tools before we start production. Second, without that initial investment in tools, without the time needed to produce tools and production setup, we are faster. And that leads to high availability and resilience in production. And third, and that's sometimes a little difficult to understand for many people, in additive manufacturing, we can create very complex geometries without an increase of cost. And that means we can take a lot of different parts and functions, put them in a single part without creating additional costs. I said before, I don't think additive manufacturing is a toy, it's a tool. So how do we actually turn additive manufacturing in a production technology? Let's compare to injection molding. I always like to show this graph. What we see here is the cost per part as it changes with the parts produced. In technologies like injection molding, we usually have a very high initial cost for producing of the tool, making the tool, and then we have a steep drop-off. In additive manufacturing, that's not the case. Without the initial investment in tools, we can start much easier. The break-even point is on the low quantity side of production. Some of you might wonder why the blue line is named AM as production alternative. The comparison we here see is one that is often made, and that is comparing additive manufacturing to another technology. Here we have an injection molded part that is designed for injection molding, designed for the injection molding process. However, in certain situations, it is very valuable to have a production alternative, especially in early production. That is prototyping. Prototyping is nothing else than having a production alternative. That is ramp-up production, where you don't have the complete production set up for injection molding yet, or end-of-life parts and spare parts. All these are examples where additive manufacturing is a production alternative for a known production technology. Let me give you a quick example what I mean by that. We have a customer that maintains public facilities, parks and recreational areas, and they operate many pumps. And one of these pumps was not longer available, but this part broke. This simple cover of a pump housing, and that meant that they had to replace the whole pump system. Instead, with additive manufacturing, we were able to replace the part and thereby extend the lifetime of the pump. That was 5 years ago, and that means this single pump has now an extended lifetime of 5 years. This is an example how with additive manufacturing we can reduce downtimes in production, extend our lifetimes of production machines, and in general react quickly. But this is an example where we used additive manufacturing as an alternative for another production technology. The original part was injection molded, but for different reasons, the mold and the production process was no longer available. And here we used additive manufacturing as an alternative. And that is very great. However, not all parts can be produced with additive manufacturing. And this is why we often need a design optimization process. Design optimization means that we take the part and make it better printable. We design it in such a way that we use less post-processing and that we overall lower the costs. Here was simply adding a surface so that we don't need support structures. We also changed the material. This is a fiber-reinforced PA. But I want to make very clear, we have AM as a production alternative, and we can make the use cases much bigger by design optimization. Here we still compare a traditional produced product with injection molding to a production alternative. Now, what happens if we think differently? What happens if we go away from the existing part in our mind and take additive manufacturing into our mindset as a prime first production technology we want to use? Then this happens. By changing the mindset and producing parts to be designing parts in such a way that they are produced for additive manufacturing, we can lower the line and make additive manufacturing actually the best tool for the job. This is what we do. This is what we can see at Formnext in a lot of examples. These are often these heat exchangers that are the gas turbines or rocket parts, but it doesn't always have complicated. I want to give you a simpler example. We have a customer that operates and maintains these water ski parks. This is basically a ski lift on the water. And what we have here is a very traditional part designed in the 1970s, like you can see in any machine shop. Very simple function. This is the end of the rope that the person hangs onto. The rope is grabbed, transported to another location, and then released by spring load. They came to us with the idea to reduce the wear and tear. As you can imagine, we have a lot of wear and tear by two metal parts on another. But then we did something we always do, and that is step back, zoom out, and see what the actual problem is. And what we saw here, we have a very traditional designed part, how it's done in subtractive machining. These are many different components welded together with a lot of production steps. And what we did then is think, how can we do it differently? How can we design the part actually around the functionality? And this is the result. We have a traditional metal part replaced with a single additive manufactured component, thereby reducing the number of production steps. That is a big cost saver, reducing production steps. We also reduce the number of parts as well. Let me add here, we still kept some simple machined aluminum parts at the back, but overall there was a great cost saver by reducing the number of parts. However, the biggest advantage here is weight reduction, and not just by a few percent, but going from over 400 to under 100. Now, I said a few times now that we need to think differently, that we need to approach engineering differently. How do we do that? Well, I made the distinction between using additive manufacturing as a production alternative and using additive manufacturing for new progressive parts. These are two completely different approaches. The problem we often see is that companies who want to start in additive manufacturing, who might have some first experiences in prototyping and now want to move into actual production, they look at their existing part library, the iceberg that is visible, and do part screening on what part could be additive manufactured. However, here the outcome is very limited. Looking in your existing parts and finding parts to be additive manufactured will not really get good results. These parts are proven, your employees know they work, and they are already designed for the job they do. However, finding the unknown, thinking different ways, and creating new products in the future with additive manufacturing is quite much more challenging. There we need a bottom-up approach. That means building knowledge, shifting the mindset within the company, and creating new techniques to actually think differently in order to make additive manufacturing happen. This is the bottom-up approach. This is the innovative approach. But innovation is often easier said than done. So we asked ourselves many years ago, is there a method to innovate? How can we create structure to innovate, to create new products for additive manufacturing? There is no golden rule, but over the years we have found quite a good setup that I want to share with you, and maybe you can take some of that home to find new products in your own company. The first, and that is what many people do, is we create a moderated innovation team. And here I want to emphasize the moderated part. Creating a team to innovate, that's what many people start, or many companies start with. A team with different skill sets. However, in order for them to actually find new applications, they need someone who can moderate them, who knows additive manufacturing, who knows how to ask the right questions, who knows where the problems are, and steers them in the right direction. Now, an innovation team still needs to work together. They need a methodology. They need a way to work. Otherwise, it will just be another workload on the pile to do. We use something that's called the Walt Disney method. That basically means we divide the whole process into 3 phases. The first is the dreamer phase, and this is because we often experience that with using additive manufacturing, especially if you're in very conservative businesses or conservative industries, people are very critical. They say we have always done it the way, we don't want to change. There are these and those and that problems. So that's why we start with the dreamer phase. There it's not allowed to critique, there it's not allowed to actually work on the solution. That's where we create new ideas how additive manufacturing might be used and how we get creative input. In the second phase, we turn that into reality. That means we create concepts, we start designing and turning these rough ideas into something that is tangible. And then, most importantly, the third phase is the critic phase. We need to evaluate if it's viable, if it's economical viable, if we have problems with materials, if we have some restrictions, if we have certification. All that is in the third phase. We do this in an iterative process and collect all the information in concept fact sheets. And the reason is simple. Having the new concepts for additive products on an evaluation sheet gives us the tool to evaluate and sort them and give them a rating. We usually sort them in 3 groups. And the first one, the most important one, is the one on the right, the one we discard. Many people, especially when they want to sell machines, tell you where the good opportunities are. However, it's much more important to know where they are not. Having an answer on which parts not to do, where not to waste energy, and where not to waste budget is very important. And then we usually have on the right side the ones where we think, okay, these are projects that actually should be done, where we should clear a budget. And the whole aim of that is creating decision proposals. In the end, we need someone to sign off on start product development, and that is why they need all the information needed. The decision proposal is not only the idea and the concept, this is also a cost estimate, this is a roadmap on how to be done, this is a risk assessment and many other things. And then we can go to the decision makers and say, okay, we want to take this and this and this project and turn it into reality, we need this budget. I want to give a little quick example on how that can be done. We had a customer that produce lab equipment. Very complicated, different machines, highly detailed, high precision needed, and a lot of restrictions in the industry. And what they wanted is make the process better for the people working with the lab equipment. And this is when we formed that innovation group with some of the lab workers, with their support managers and salespeople and engineers, and came up with new ideas how can we make their processes better. And the result is to create a system of sample preparation tubes that can be used to more effectively handle samples within a whole system. and make sure that all samples are digitalized and accounted for correctly, and all samples are measured. This is a typical application for additive manufacturing because we have small quantities, we have very high precision needed, and we are an industry here in laboratory equipment where we have very high specifications. This was a quick overview on a way that we use to actually get new application into reality. I know that it can sometimes be hard. This is why I've prepared on our website some of the use cases we have. I would like to invite you to come talk to us. Maybe you want someone who can help you along the way. This is what we do, help companies on the way into additive manufacturing. Me and my colleagues are here today. Tim and Timothy are standing on the side of the stage also. And now, are there any questions?
Thank you so much, Philip. Awesome. Big applause, ladies and gentlemen, for Philip. I do have a question, Philip.
Sure.
Sorry for that. Sorry for that. But first of all, the audience, any questions from your side? Okay, let me ask you my question. I was really positively surprised about the process you presented. But I tell you what, I'm doing a lot of lean management consultancy, and this is where you train the people thinking outside the box and start following a method of problem solution or root cause analysis, whatever that is. And it's a pretty similar process in terms of it starts with a good moderation, etc. So if I explain this to very technical-oriented people, you can see in their eyes that their reaction is like, Guy, we wanted to have a method. You know what I mean? So they don't consider that as a method. What are your experience on that?
Well, my experience is a little differently. What we actually do is empower people to do it themselves. We don't want to do it for them. We want to help them, empower them to do that themselves. And that method helps to make the conversation between the different people involved. And what we always experience that people are very skeptical of using innovation methods at all. Yeah. I mean, we talk to a lot of very conservative people who have worked with the machining or on the workbench.
That's what I mean.
Heavy metal parts all the time, and they say, "Oh, don't come in with that. I want to work and want to get it done." And this is exactly why I divide it into these 3 phases, so that we can basically move the skepticism back to a later stage, after which we have already created the first solutions.
Yeah.
And another thing that's always good, start small, give them first great examples to actually solve their own problems, and then you go step by step from there.
That's an important point. So if you start with them the process, how difficult is it to get them out of their, let's call it, how do we call it? That's a good question. Let's call it traditional thinking.
Okay.
So how difficult is that? So usually coming up with, we thought about that. That would be the solution.
No, that's exactly the wrong thing to do. If we as outsiders go there and say, this is what you need to do, the project will fail, almost guaranteed.
Yeah.
We need to empower the people and to give them the tools to actually solve the problem themselves. And what we found is, ask question, where are your problems at the moment? What are you struggling with? What is the thing you want to change in your daily work, in your, whatever it is, an assembly process? And from there we can see, okay, here we might go in and actually help you make your job easier, make your job better, and your life in your company better. And this can be little things. We can start with a holder, a tool, a guide to drill the hole at the right place. These are the things we usually start with. And then you can build very quickly from there, but after you have gained the trust for the technology.
Now, you are an AM enthusiast, so
definitely,
which makes it sometimes, of course, more difficult to be neutral. So have there been cases where you needed to say, hey guys, listen, let's do it the traditional way. The way you're doing it is fine. Optimize the process, whatever. Is that sometimes the case where you say, I don't think AM will help you?
This is the most important word in my vocabulary. Louis is saying no.
Yeah.
We are often asked or consulted by companies who are unsure yet if additive manufacturing is the right tool for them. And we took the strategic decisions to not sell machines, to not sell the parts, to not sell software. simply to be able and be in the position to say no. And we do that often and a lot.
Yeah.
We actually turn the process around quite a lot of times, meaning we actually want them to say no. We want them to say no 3-4 times to additive manufacturing. And then when we have a yes, it's a clear yes, and you can work with it and actually make great things happen.
Very good, very good. Philip, excellent presentation.
Thank you.
You convinced me, at least. I mean, this is for sure. I don't know the others. Have he convinced you? A quick survey here. So raise your hands if you are convinced now. It's not the majority so far, but
we will change that.
Thank you so much, Philip. It was a pleasure. I will see you in a few minutes, basically, in our panel discussion. Okay.
Looking forward to.
See you there. Thank you so much. Big applause, ladies and gentlemen. Phil Süß. Yeah, ladies and gentlemen, we will provide you, of course, with some more highlights. And I don't think it's the last time I will say that today, but please don't forget to vote for Formnext Awards. The colleagues are so kind to giving you the QR code to do so. And stay tuned in our program, because in just a few minutes, we will have an amazing panel and we will discuss real business cases and real things to observe in additive manufacturing. So stay tuned. See you in a couple of minutes.